Hello and welcome back to the third episode of Maths with Hamblin with your beautiful host Hamblin. And today, my boys, we're going to cover simplifying expressions involving surds, square roots, cube roots, the like. And we're going to do it using the rules we learned last time about indices and exponents. So let's get right into it, my boys. Okay, so let's do some simplifying then. So what I mean by simplifying expressions with surds is, well, reducing them until you get them into nice smaller numbers, some nicer numbers, not like terrible irrational numbers, like rational numbers. Now, I'll explain how we're going to do this first. I went into it a little than last time, but let's do it now, shall we? Now, so root 12. So to simplify this, we're going to want it to get it into a form where it's got some nice numbers and smaller numbers. That's what it means by simplifying. And usually, these are really good, easy marks on exam questions. So let's try it then. So we know that we can say 12 is equal to 3 times 4. So we can say that root 12 equals the square root of 3 times 4. And using the indice rules we learned last time, we can split that square root expression into two little square roots. So that equals root 3 times the square root of 4. But the square root of 4, everyone, we all know that to be 2. Nice little number 2. So this is equal to root 3 times 2, or if we just write that nice and compactly, 2 root 3. So there we go, that's how you simplify individual little square roots like that. What we've done is we've taken it and we've meshed with it a bit until we get it into a nicer form with some nicer, smaller numbers, so we've simplified it. And that is the general technique. If you're looking to simplify just a single surd, make it nice and better, you can just think about, well, what are its factors? See if you can get any nice square numbers so you can pull them out, crush them with the square root, and make them nice and dandy. Right, now let's look at this one. The square root of 3 divided by 16. Now, it's not easy. I only proved this that you can break a multiplication of two surds out, but you can just use, that has to be a nice exercise for you actually, to prove that if you have the square root of a of b, that equals the square root of a divided by the square root of b. It's not very hard. Follow the same lining of reasoning I used in the last episode. Anyway, so this is equal to the square root of 3 divided by the square root of 16. Now, just like last time, look what special things we've done here. The square root of 16, that's the square root of 4. No, not the square root of 4. It equals 4. So that equals root 3 divided by 4. And now we're done. We haven't got anything else we can really do to this. And we've simplified it fully, put a box around that, big tech. We've done it. So there you go. There's the general strategy there. Let's do the next one, boys. Okay, so the next big thing we're going to use is what's called rationalizing the denominator. Now, as you'll notice with these expressions above me here, they've got pretty horrendous denominators. They've got irrational denominators. Now, you can imagine if you were trying to work out what the actual value of these things are, having to divide by an irrational number is pretty, it's not good, right? But adding and multiplying by irrational numbers, that's pretty nice. So, what we mean by rationalizing the denominator is using some algebra to manipulate this so we get a rational number in the denominator instead of a horrible irrational number. So let's figure out how to do that, shall we? Now, the 9 over the square root of 3, we want to get rid of the square root of 3. So how do you get rid of a square root? Well, you can just square it. So we're going to try and find out how we can multiply the bottom by root 3. Well, as you know, we can just multiply the top and bottom by root 3 because that's the same thing as multiplying by 1, which doesn't change anything. So that equals 9 times root 3 over root 3 times root 3, which equals 9 root 3, and then root 3 times root 3, by definition, that's a 3. But are we done? No, because look what we've got, 9 over 3. 9 over 3, that's just 3. There we go, boys. We've simplified 9 over root 3 to 3 root 3 by rationalizing its denominator. Pretty easy. This is a bit of a harder example you might see because we've got a binomial in the bottom here. We've got 1 plus the square root of 2, but not to worry. There's a nice little algebraic identity we can use to simplify this. You can prove this pretty easy. A squared minus b squared, that equals a plus b times a minus b. Sorry if you can't see that too well, but that's the thing. And if you don't believe me here, just expand these two brackets and you'll wind up back with that. Now, you can see why this might be a very, very powerful tool for us to deal with here, because look what we've got. We've got 1 plus the square root of 2. Now, if we found a way to multiply that by 1 minus the square root of 2, we can just rewrite it as 1 minus the square root of 2 squared, which is just 1 minus 2. So, using this great little, really useful algebraic identity, you should put this to memory. Commit that to memory, alright? That's my favourite from you to me. Right. And so we can just kill surds by using this identity. So let's do it, shall we? So let's multiply the top and bottom by 1 minus the square root of 2. So we're going to get 1 minus root 2, because 1 times 1 minus root 2, just 1 minus root 2. And then over 1 plus root 2 times 1 minus root 2. Now, using our little identity here, this is going to be the same thing as 1 squared minus root 2 squared, which is 1 minus 2, which is negative 1. So that equals 1 minus root 2 over negative 1. Now look how nice that is. We've just got a lovely rational number. In fact, a lovely integer in the denominator. But we're not done really, because we're dividing by a negative. We can distribute that negative. That's the same thing as negative of 1 minus root 2, and then we can just distribute that negative. Then we get negative 1 plus the square root of 2. Boom. We've simplified that horrible, disgusting surd into something nice and beautiful. Let's look at the next one. Okay, so this next one is a very common type of exam question you might get. It gives you this kind of horrible thing, and it asks you to express it in the form of a plus b times root c, where a, b, and c are all integers. So what's the most obvious thing we can do here is we can expand it, and when we expand it, we're going to get a lot of squares, and a lot of square roots are going to get crushed, which is exactly what we want. So let's expand it. So we're going to get 2 root 5 squared when we expand this, plus 2 times 2 root 5 times 3 root 6, then and then on the end we're going to get a plus root 3 root 6 all squared. Now, this is a lot of rules we can use here, so let's use them. 2 root 5 squared, that's 2 squared times root 5 squared, in other words 4 times 5, which is 20. That first bit there's 20, right. A lot of stuff we can do here. 2 times 2 times 3, that's 4 times 3, which is 12. And then we've got root 5 times root 6, which is root 30. So we've got 12 root 30. And then this last bit, 3 root 6 squared, using the same logic as before, that's going to be 9 times 6. 9 times 6, if I'm not mistaken, is 54. 20 plus 54, that is in fact 74. And then we've still got this 12 root 30. Right, absolutely smashing, my boys. Now, we can look at this root 30 and we can think, are there any two square numbers that multiply to give 30? Well, any factors of 30 that are square numbers, I think. Well, let's check. 4, not a multiple of 30. 9, not a multiple of 30. 16, that's not one either. So actually, we can't. But we've simplified all this together, and we've done what the question asked for, because we've expressed it in the form a plus b times root c, where a, b, and c are integers. So that's the next bit of simplification, my friends. And that's pretty much it for surds, for simplifying them, to be honest. Now, I've been told by many people to shorten these videos down, because apparently most people don't have the attention span to watch a half-an-hour video about maths. I know, right? The nerve of some people. So I am going to cut this video here, and I'm going to leave you with a problem to do, which I'll write up shortly. Thank you very much for watching Maths with Hamblin Part 3. The next part of this will be, I'll actually go through some problems with this. I'm not just going to leave you hanging like this. So, thank you very much for watching, and I'll see you in the next part, which, by the way, should be uploaded only like an hour after this one. See you then. That's the problem I'm going to leave you with, and the problem is to express that bad boy as in the form a plus b root c, where a, b, and c are all integers. Good luck with that one, my friends. Catch you later.